respecting everyone's time, let's get started with our speakers. Amit, please take it away.
Thank you, Triparna. I will begin as soon as we have the slides ready. Okay. All right. Good morning, everyone. So what we will discuss today is mainly around API testing. What are some of the focus areas around it? And we are extremely excited to also have Manoj Ranganathan with us, who will do a demo on one of the platforms that we have been using extensively. What are some of the features of that platform and how easy it is to actually implement not only a functional test, but also performance and your security test using this platform. Eventually, we will also discuss about why you might need some expertise in this area, and it might not be a good idea to do everything in-house. And depending upon the time, we will also do a few questions and answers. So without any further ado, let me quickly introduce Parker Digital. We are now into our 9th year of operations, working with more than 90 enterprise clients across 10 different time zones. We have 300 plus cloud educated engineers with various specializations, and many of them are certified to work on multiple clouds. Some of the esteemed customers, and these customers are all across the domains. We do have a center of excellence on the healthcare domain as well as fintech and the retail space. But as you can see, many of these customers are Fortune 500 customers. Many of them are at the startup phase. But we have helped plenty of these customers not only work on product engineering, but also on their data and analytics side. Now, these are a few partnerships that we have developed and nurtured over the years. So besides AWS, Azure, and then GCP, we also have an extremely good partnership with Science Logic. We are currently working on a couple of plugins or applications on the Jira and the Atlassian marketplace. But more importantly, on the platform operation side, ServiceNow, Terraform, Zabbix are a few of the platforms that we have partnered with and have been using extensively across our engineering. Now, almost all of what we do fall into these 5 verticals. On the left-hand side, we have the product management area, where we engage with many of our customers to do a detailed discovery or assessment of their needs, and then come out with a product roadmap that includes engineering backlog and MVP, marketing, and also the go-to-market strategy, to name a few milestones. On the user experience side, we have a lot of experience in conducting a UX assessment to understand the gaps and then come out with recommendations on improving them with respect to industry-leading benchmarks and then setting up of new ones. This, more often than not, is an afterthought in the engineering implementation, but a very critical aspect to drive your design and user experience. The next one is product development, and pretty much our bread and butter in everything that we work on. This includes working on greenfield applications, modernizing or refactoring legacy applications, or migrating some of these on-prem workloads to the cloud. DevOps is a critical component of this, where we have automated provisioning of environments and release deployment pipelines using some of these industry standard templates and frameworks. Once an application has moved to production, we also have 24/7 teams to sustain and monitor these apps. We have used standardized tools and platforms in our operations team and have around-the-clock operations for network, operating systems, infrastructure, and application support. We have recently added a SOC capability, extending the support for many of our critical customers. Finally, our data, we do have advanced capabilities in data analytics, both for product and end users, be it Google Analytics or Adobe to get user insights, or use Azure Data Factory or Snowflake for data lakes and in real-time data engineering. We have worked on pretty complex data use cases and will table it for another time. Now let's get on to the meat of today's agenda, which is the API testing part. APIs or application programming interfaces serve as the backbone of modern software development. They facilitate seamless communication and data exchange between different applications, systems, and platforms. APIs enable developers to leverage functionalities and services provided by external integrations, unlocking new possibilities and fostering integration. According to a study conducted by Akamai, 88% of organizations consider APIs extremely important for their digital transformation initiatives, enabling them to create new revenue streams, enhance customer experiences, and improve operational efficiency. Now, what are some of the key aspects of API testing? There are multiple aspects and dimensions of API testing, and most of them are listed here. Most organizations spend 90% of the time on functional testing to verify that the API functions correct, that the APIs work correctly by looking at different API endpoints, methods, and input-output scenarios. This also includes verifying that APIs meet the business needs and that behavior have a direct and immediate impact on user experience. While functional testing is important, it is also crucial to have a balance between this and other aspects of API testing. For example, evaluating and establishing benchmarks around API responsiveness, scalability, and efficiency under various loads and work conditions form an important component of performance testing. Similarly, ensuring the API behavior and protection against vulnerabilities, unauthorized access, and data breaches constitute security testing, which often gets ignored. Comprehensive API testing strategies encompass all of these areas to ensure a well-rounded evaluation of the API's quality, reliability, and effectiveness in meeting organizational goals and user expectations. Typically, all of these diverse testing strategies require different skills to achieve their goals. However, having a comprehensive testing platform that includes multiple API testing types empowers the QA organization to achieve broader coverage, detect issues early, enhance quality and reliability, mitigate risk comprehensively, improve collaboration and communication, streamline testing processes, and leverage automation and reusability. This ultimately leads to the delivery of high-quality APIs that meet user expectations, ensure customer satisfaction, and contribute to the success of the organization. I will now invite Manoj to discuss about one such platform that we have been using and how it has helped our teams and, most importantly, our customers.
Thanks, Amit, for the good introduction about our today's session. Welcome all. So I would like to just give some details about our platform and a short demo at the end of this session. And before that, just I would like to give a brief introduction of what is that API testing platform and what are some of the attributes of it. An API testing platform helps streamline and optimize the API testing process by providing automation, centralization, scalability, flexibility, reporting capabilities, and it also has to integrate with other external systems. So it enhances the efficiency and reliability of API testing, ultimately leading to improved API quality and better customer experience. So some of the key attributes I would like to just highlight is automation and efficiency, and it has centralized test management, reporting and analysis of the reports, integration and collaborations of it, and then supporting multiple testing types, like it can be a Swagger or REST or some other standards we are using. So in a platform, we do not need to remember on what test conditions and API worked fine. So we should be able to just publish the thresholds and based on the parameters we set during the time of testing. So similarly, we also understand the security threat the API cannot withstand. Some might fail for basic SQL injections, and some might fail during the corner boundary cases. So we should be able to at least have everything in one place. That's what we call it as a platform. So some of the attributes I would like to highlight here is scriptless API testing. So we all have the habit of writing scripts for our APIs and testing them. But then how about an environment that supports no code test automation, especially for the API by validating the written codes and the output. So in addition, the platform checks for latency in the response, right? So that is one of the key attribute. And performance testing, I mean, test the API and load time by setting different parameters, like your what should be the load and then peak load, and by varying the loads during our testing process. And security testing is one of the highlighted attribute here. I mean, to test the security of the API by applying various security policies, and analyze the API's reliability and exposure to vulnerability. So, and in addition to that, we have API virtualization. I mean, it's setting up a virtual API environment in your local or private cloud to analyze the traffic and performance. And so test automation is something automate the API by creating test cases and the steps for the series of APIs to be called in the same test case. So it's like inbound and outbound. So I have an API and then I cannot call the API as complete without testing the subsequent APIs. So you can all have a kind of test case where you can add multiple steps in between and call different set of APIs and then test them in completion. So without taking much time on that platform details, let me quickly move on to critical API testing types we would like to focus today. The primary one is the basic one is our API functional testing. And functional testing, I'll also talk about some of the key attributes of this functional testing. And so what's the functional testing, right? Testing ensures that the API performs exactly as it's supposed to. And this test analyzes specific functions within the code base to guarantee the API functions within its expected parameters can handle errors when the results are outside the designated parameters. So the test cases for the functional testing will be a standard approach where the QA understand the requirement and write the test scenarios based on the API documentation. So the team also combines the series of APIs to be called before and after, ensuring that the desired use cases, right? So any platform that gives flexibility of sequencing or combining them without writing additional scripts to perform the test cases will definitely improve the productivity of the team. Right. So I'll touch base a little bit more on the functional testing best cases. So with all the experiences we have in-house and by implementing this on various customer environment. So we have some sort of best practices which we identified. We thought we'll share it to the entire forum here. Right. So one is the basic thing is our API documentation. Like start by thoroughly reviewing the API documentation, understand the purpose of the API, what is the expected behavior, and the constraints of each API endpoint, right? That's primary in understanding. So anyone who would like to test, even write a single unit test cases, they should be able to understand this thoroughly. So without that, they won't be able to do justice to the test cases they are writing. So input validation is so validate all the incoming and outgoing data for correctness, accuracy, and completeness. So test the API with both valid input and invalid input data to ensure proper error handling. And so the response validation is again, so the way we are handling the input, we also need to see whether the response is valid and it is giving the right results, and even it is giving in the right time. Suppose I'm expecting the API to return some set of values in a given milliseconds or seconds. So ensure that it is meeting the requirement. Without that, it's going to be very slow when you deploy that in production. So authentication and authorization, I mean, test the API endpoints with different authentication and authorization scenarios, including valid and invalid credentials to ensure that the access is restricted appropriately. And so there are a lot of other attributes, but I'll just highlight only the handling error responses, right? Verify that the error response are returned when they expected, and then they contain the right error codes, error messages, and other relevant details, and testing different error scenarios to ensure proper handling. And in a way, we should be able to report this to our end users or the development team whenever we find that right responses if it is not giving the right answers. So error logging and reporting is another main area I would like to highlight. We test it and we record them everything in a different set of document or maybe acceptance criteria. Maybe our platform is going to show that it can be stored and you can generate a report, and then you can integrate that with an external system. We can directly upload the report in that system, so it can give the detailed in-depth analysis of where it failed, right? So that's one thing I just as mentioned as a best practices here. Yeah. So my next in the list is about performance testing or load testing. This is load testing is used to see how many calls an API can handle. I mean, this test is often performed after a specific unit or code base is completed to determine whether the theoretical solution can also work as a practical solution when acting under a given load. So the platform should allow us to use our functional test case scenarios to be used as a base for the load testing. So in a nutshell, it is going to be like I've written the unit testing, I've written a kind of functional testing. Can I use the same set of test cases to do my load testing instead of writing new test scenarios? So I remember when I was like doing all that, managing a bigger team. So we had a team for your functional test cases, and then integration testing, and then we have a different set of performance testing team. I mean, they all have right to write different set of test cases, and so to ensure that the performance is tested. So this team helps to write test cases for different scenarios and come out with the benchmark numbers to be published to the client, which will also be the baseline for our deployment architecture of our solutions. So this will also help us to fine tune the auto scaling approaches we talk about these days, and the hardware requirements for the deployment, right? So if certain load cannot be handled, but I know my application requirement is going to be some millions of users at the same time, then I decide what is my peak load this application can handle. Then I can also auto scale my application based on that my study of this performance testing. So some of the best practices we also have wanted to just highlight here is, so again here, identify your performance goals. Define the performance goals for your API, considering factors like expected user load, how many concurrent users be accessing this system or API at a given point of time, what is the response time. This helps set a clear objective for performance testing. And again, a load and stress, I don't want to specify it as a separate one, but then this is again part of your how your system is going to be working under different load scenarios, and peak load, and then gradually increasing load. And so how do you do a stress test and then concurrency testing, and depends on based on the output of it, and we should be able to just come out with a standard. If I know I have a very B2B and I know I don't have a bigger client base for this, then I don't need to spend too much of time in doing a stress test or load test of for millions of users, right? So that those kind of parameters will definitely help us to define what is my application and how do we test it. And caching and session handling is something we need to really consider. I mean, consider caching mechanism and session handling in your performance test. Test scenarios with the cache data, as well as scenarios where sessions are initiated or maintained to validate their impact on their performance, right? Some people will have a login and then they just keep it as it is. Does it impact your subsequent or concurrent user base? So we have to just handle how your API is going to be working on that as well. So database performance is another critical best practice we need to consider. Consider the impact of database operations on API performance. Test scenarios that involves database interactions and measure the response time and resource usage during these operations. And performance tuning, identify performance bottleneck and tune your API accordingly, right? Optimize database queries, use caching mechanisms, improve code efficiency, and fine-tune server configurations to enhance overall performance of it. So other one is performance monitoring. This may not be a kind of the best practices, but however, this really helps us to decide how the API is going to be. And this is one of the key parameters that once it is in production, the monitoring team is going to be very keen on this one. So this will also trigger an alarm if the performance is not really good. So monitor the performance of the API during load test, collect and analyze performance metrics in real time to identify performance issues, bottlenecks, and resource utilization patterns. Like tools like JMeter and Gatling or Apache can help with performance monitoring. So this is some of the best practices for performance testing. So the next one is about the one of the critical thing in any of the test scenarios or any of the application lifecycle, right? Security testing. Security testing attempts to validate the encryption methods the API uses, as well as the access control design. So it includes the validation of authorization checks for resource access and user rights management. This one is a kind of prime importance in any of the testing cycle. Many organizations run bounty programs to identify the vulnerabilities in their applications or APIs. A minor mistake in any of this, anyone overseas will definitely cost a lot for the organizations. So we need experts in this domain to guide us on the approach to our API testing towards any vulnerabilities. So what if the platform helps to build some of the scenarios and run the test based on our functional test cases, where most of the underlying tasks are taken care by the platform. So this helps to identify the issue early in the stage than at a later point in the lab environment, where the cycle time is more to fix and run the complete test scenarios. So we'll touch a bit more on how you can use your application, the functional testing scenarios in to easily generate your security testing as well. So again, here I would like to just highlight some of the key best practices and takeaways for you all in this forum. Again, it's going to be authentication and authorization. Test the authentication and authorization mechanism of your API. Verify the user authentication is enforced correctly and that access to sensitive resources properly restricted. I mean, no matter what your input or input is going to be. So validate and sanitize your, it's about input validation, right? So validate and sanitize all the input data to prevent common security vulnerabilities such as SQL injection, cross-site scripting, or XML or JSON manipulation. Test the API with various inputs, including special characters and malicious payload. And so parameter manipulation is something which is normally we do. Test for parameter tampering by modifying parameters in API request. Check for unauthorized access to resources, privilege escalation or data exposure by manipulating parameters. You manipulate some parameters which is not handled well, it is going to just return some sort of data which we think it is not exposed, which should not be exposed to anyone. but then some error in our API, which will definitely expose at least the usernames or something else, depending on where the leak is, right? So API rate limiting is one of the key attribute. Test rate limiting mechanism to prevent abuse, excessive request, or denial of service attacks, right? Like a kind of honeypot. You just expose some of your API where customers can just try to hit it, and then you see from some of that IPs you are constantly getting a request, and you just block that, assuming there is a kind of attack which is against your system. So you need to ensure that you have the API rate limiting, which is a critical aspect in our security testing. Again, session management, we talked about earlier, which it talks about how do you handle your session or verify that session tokens are securely generated, transmitted, and stored to prevent session hijacking and replay attacks. And security headers is another key attribute. Check for the presence of security headers in API response, such as strict transport security HSTS, and then content security policy and XSS protection. These headers help protect against various type of attacks and enforce security policies. So again, the main thing is vulnerability and then penetration testing, the pen test we generally call as. Perform your vulnerability scanning and then penetration testing on your API. Use tools like OWASP and Nessus or Burp to just frequently or once in a month or once in a fortnight based on your critical requirement, and then identify common vulnerabilities and potential security weakness so that you have a right team to fix it before it's too late for any one of us. So that's the thing I just wanted to highlight before I just get into a demo. And now let me quickly show a kind of demo here about the platform I'm just talking about. Just give me a moment's time. Let me share my screen. Where is my share my screen? Okay, I'm sharing my screen right now. I hope you all can see my screen. All right. So this is the platform I was just talking about, where you'll be able to. I just give a kind of overview of it. You'll be able to write functional tests in this. I mean, we have a lot of projects in parallel. So I just added it, and for demo purpose, I've just added multiple other applications. And so where you can just come to this application, and then you can start writing a simple functional test cases here for a simple API request. And this is the one. I mean, to simplify, I just added some openly available API to showcase it to you. And so it's very simple use case to begin with. So we have an endpoint explorer where you go and give the endpoint in this, and then just a second. Right. And then you can just do a create test, which is going to create a test for here, and it will create a test, and it will also add a corresponding API which we are using it. And so this is one of the test cases we have. And then you just come and it's a get method, so you just come and execute this. Let me just yeah. So you run this here, and then see what is the result it is giving, and these are the result. So this is one of the API where you're just going to get that what is that current rate of the Bitcoin. And so this API is from a CoinDesk, and I just use it for to simply show what is the output of it, and it is going to say what is your current rate. It goes and hit the server, and it is going to get the response of it. And this is the test case. And then if you want to add more test cases to it, we can also go and show, we can add some more test cases. I was mentioning about adding couple of more in the test cases. You need to add couple of more tests, so you should be able to add that. And so you still able to run this, generate it, and then see what is the response. That is what we just showcased here. And so it's going to see whether it's a success or a failure, and see what is the return code. Right? These are simple APIs where so yeah, I mean, this is something which we are not even subscribed for. And then we have another API where we can just go and showcase. You just hit that. So what I was talking about is, for example, I have my functional test cases which is added here, and I used to test it. Now I need to show whether I can create a basic security or performance test based on my functional test cases, which I talked about. Then we just go and create. Just a second. Yeah, so I have a load test here. So from my functional test, I can just create a load test with a click of a button, where I can just select all the different loads here, and what is my load and what is the scenario. And I can create all that. And I have other parameters as well to schedule it. For example, if I take this one, I can just go and create one more create load test. While creating a load test, I can just mention for how many seconds I need to run. I hope you guys can see I've selected 5 seconds here. And what is my virtual simulate user behavior, like how many virtual users I need to select. So I should be able to give all the parameters here, so that so percentage of virtual users and fixed load. So this is what one of the scenarios I was talking about. What will be my initial load, and should I have a kind of gradually increase my load and see how my performance is for the given API or test case. Or I can just give a different set of load, and then I set all these parameters and see what is that I wanted to see. And then when I just run this, so I'm just running against I've just created a new um, performance test here, and see it is giving me the results in this one. And maybe for some reasons it is failing, but there are other scenarios where it generally be a successful one. And the end of that, when we run all that scenarios, it is going to generate a kind of report where you can at least show what is your peak load, and how it is, and what are the different scenarios where under what different conditions it used to run it. And it also show what are the failures of the system. And so we can say it's giving a different set of return codes. These are part of our testing, and then you also see what kind of report it is generating. So based on my functional test cases, right, this is how you can just perform a kind of a load testing without writing any additional code. I mean, you literally did not write any code for this one. You return a kind of functional test cases, and based on that, you started creating a kind of performance test. So next one is, with a similar condition, we can also create a security test here. And let me give an example and see whether I can create a security test. Yeah, so we have an option here to create a security test. And when you create a security test, I mean, as I mentioned, you need a domain expert to see what kind of testing you need to need. But this platform gives an ability to select what are the kind of tests you wanted to run against this API or against the test cases, right? So I don't need to give a whole lot of things. It takes more time to run in our scenario. So I just wanted to select very few. You can decide which one you want to do, whether you want to do a cross-site scripting or a SQL injection or XPath injection. You can select that and say, and these are the parameters, and you need not know any technical in-depth knowledge about this, but you can select what are the things you want to do as a first go. And then you execute that. It is going to give you kind of so there could be various reasons for that test failure. However, so it still can tell you what is the report of it, right? So there could be any reason for this failure. I can generate a summary report here, and the output of the report is going to be something like this, where it's going to tell you what is the kind of security test it has performed. And so it says these are the errors which are available. So ideally, there could be some false positive, which we know, maybe which can be fine-tuned in a production environment. For example, if the response time is greater, then you can add an assertion to that. If my assertion is something which is less than 10 seconds or less than 3 seconds or maybe 10 milliseconds, you can add those assertions and you can skip it during a test cycle. But we know it for sure. This can be done during our production cycle, or maybe a pre-prod environment where it is exactly similar to your production environment, and you still be able to show a kind of performance improvement there. So this is my another project where you have my functional testing, and I have a test scenarios here where I can just select it. See, in this case, right, it's my only single test shoot, and it's a test case, but I have two APIs to test it. There's one of my functional scenario. And then based on that, I created a security test based on that, and I can just run it where it can run based on the right hand side. You can see what is that it is running, and then what is the response it is doing. Right now, it is doing a kind of cross-site scripting. So in this case, I selected only boundary scan, cross-site and XPath injection, where it is running against the API, and which will publish the results. It can be success or failure. Then it gives a report. Based on that, we can analyze and we can attach this report in our vulnerability scanning to our development team. So they can take a look at it and then completely come out with the solution for this, and they can fix it. So you can retest it again. Then you don't need to recreate all that test scenarios. I mean, we generally don't do it. You still can run this and rerun the test cases and then publish the report and compare against your previous run. So it also gives a history of previous runs, and you see whether it's a failure or success in your past run and what is the current results of it. So this is a kind of overview of a demo I would like to just cover, because we talked about how easy it is to create a functional test cases, and then how easy it is to add multiple test cases inside a test suite. And then from your functional test cases, you can easily create a load testing for the same set of test cases. And from the functional test cases, you will also be able to create a security test. During the security test, you will be able to select multiple parameters, even though you're not an expert in the multiple security aspects of it. But the system can provide the basic things for you to test it and then report it. So in a nutshell, it's going to provide all the required scenarios for a kind of testing team on their day-to-day life. So this is a demo, and with that, I would like to just transfer it to Amit to cover the remaining part of that seminar.
All right, thank you, Manoj. So
Yeah.
if I could request the team to also share the PPT again, please. All right. After that, so when selecting an API testing partner, it is important to consider several criteria to ensure that you are picking the right one. Here are some important ones. I will begin with expertise and experience. It is important to assess the partner's expertise in API testing and their experience in working with similar technologies and domains. Evaluate their track record in successfully delivering API testing projects, including the complexity and scale of the APIs. You should also look for any certifications, relevant case studies, or testimonials that demonstrate their competence and industry recognition. Talking about technical skills and tools, it is important to evaluate the partner's technical skills and proficiency in API testing frameworks. It could be open source or it could be platforms, tools, and methodologies. Consider whether they have experience working with the specific API technologies and platforms are relevant to your organization. Determine if they possess knowledge of the latest industry trends, standards, and emerging technologies related to API testing. As you are aware, all of these standards tools are getting updated by the day. So it is important for someone who understands, who is doing API testing for a living, and is able to incorporate some of the latest tools such as AI into their frameworks. Talking about collaboration and communication, you should assess the partner's ability to collaborate effectively with your internal teams, including developers, testers, and project managers. Consider their communication skills, responsiveness, and willingness to provide regular updates, feedback, and status reports. Ensure that they can work seamlessly with your team, aligning their processes and workflows with your organization's requirements. Everybody works in an agile mode. It is important to ensure that the partner is also agile and not just mandating their own processes or tools. If you already have an ecosystem of tools or individuals working on API testing, how can this collaboration be improved? Let's discuss security and compliance. So let's consider the partner's knowledge and expertise in API security testing, data protection, and compliance with relevant regulations. For example, GDPR or a HIPAA, as a few examples. You should also evaluate their approach in identifying and mitigating security vulnerabilities, ensuring the confidentiality, integrity, and availability of your data. This is often an ignored area, but is extremely important before any of your APIs or applications can go live. Talking about scalability and flexibility, you should assess the partner's capacity to handle the scale of your API testing requirements, including the number of APIs, endpoints, and the expected workload. Consider their ability to adapt and accommodate changes in your API landscape, such as updates, versioning, and new integrations. Cost and value. Always evaluate the partner's pricing model, considering the value they bring in terms of expertise, efficiency, and effectiveness. Compare their pricing with industry regulations and other potential partners while ensuring that this does not compromise the quality of work. Finally, about references and reputation, you should always seek references and feedback from other organizations that have worked with the partner on their API testing projects. Research their reputation, customer reviews, and ratings on reliable platforms to gauge their overall performance and client satisfaction. I would be happy to say that Parker Digital comfortably ticks all of the boxes mentioned here, and we are extremely happy to share any references that might be needed. Now let's discuss the typical benefits that you can expect when you leverage the strengths of an API testing partner for all of your testing needs. Partner involvement enables a broader perspective and ensures comprehensive test coverage. They can identify critical scenarios, edge cases, and potential issues that might be overlooked otherwise. Risk mitigation. Partners and SMEs bring a fresh set of eyes and perspective to your testing process. Their input helps identify and address potential risks, vulnerabilities, and security concerns, reducing the chances of major issues in production. Industry standards adherence. Partners and SMEs can guide the testing strategy and teams to align with industry standards, ensuring compliance and interoperability with other platforms and APIs in the ecosystem. You also get access to specialized skills. So choosing the right partner and team often gives you access to a team of specialized API testers with diverse skill sets. They can bring expertise in areas such as performance testing, security testing, automation, or any specific industry domains, enriching your testing capabilities and ensuring comprehensive coverage. We have also seen plenty of instances where this has allowed for you to use your internal teams more effectively while leaving the onus of complete API testing from functional and NFR to a vendor like us. Flexible resource allocation. By partnering with an external team, you gain the advantage of flexibility in resource allocation, which is what I was discussing earlier. You can scale up or down based on the project requirements, leveraging the partner's testing resources as required. This flexibility allows you to optimize your cost and ensure efficient resource utilization. Finally, continuous improvement. Ongoing engagement with partners and SMEs fosters a culture of continuous improvement. Feedback and insights from multiple perspectives can be used to refine the testing strategy, enhance processes, and optimize the API's performance. A reputable API testing partner can provide ongoing support beyond your project completion. They can assist in setting up continuous integration and delivery, your CI/CD pipelines, implementing test automation frameworks, and conducting regression testing to ensure the long-term stability and reliability of your APIs. By partnering with an API testing specialist, your organization can focus on its core competencies and strategic initiatives. This allows your internal teams to concentrate on development, innovation, and other critical tasks while relying on the partner's expertise to ensure robust API testing. With that, we come to an end to today's workshop, and let's see if we have any questions and answers or any questions asked. So the first one is, what is the platform name and is it open source? So Manoj, feel free to jump in, but the platform that we were demoing today was Ready API. We have customized the platform to our requirements, to what we have seen as the most commonly used features for our customers. It's not open source, but it will allow you to use a free version for at least your basic needs. The next question is, how many threads can be simulated? Now, I will have to look at the data sheet, but if you're talking about how many concurrent processes can be fired or how many V users can be simulated, I'm sure it's in the thousands. You can simulate any number of V users that you want. And about the number of the processes, I believe it is 4, but Manoj can correct me if I'm wrong.
Yeah. Right now during the demo, we use some standard template. So that's why all the values are auto-picked. But then if we use a manual, then based on our customization, we can customize a lot of other parameters as well.
Okay. Now, are these security tests black boxed? I need to know which type of security tests are running. So they are not black boxed. You do get insight into which kind of tests are running and what are the default parameters that the tool has picked up for you. For example, if it's an XML bomb or say cross-site scripting, you will be able to look at the API request and response and be assured that we don't expose or we don't have any vulnerabilities in your API platform. Does this tool support data-driven test? Now, this is one of the beauties and flexibilities of this tool. Besides using out-of-the-box functionalities, you can use extensive scripting. So you can introduce your own loops. You can introduce your own looking at an Excel file or maybe a database to pick up the data values. So you can customize, you can extend the functionality of this tool. And now it's only limited to the scripting experience that you or your teams might have. Finally, is there a place where I can write some testing scripts for the sake of testing or piece of code that can generate an input? Can I add assertions and in which programming language? Now, we have used plenty of open source frameworks. We have used Rest Assured, which is extremely flexible in writing your own API automation, and it's mainly on the Java side. but I have seen plenty of frameworks written either on Groovy scripting or Python. Now, can you write or can you generate any piece of code? Can you add your own assertions? Absolutely.
Yes.
You can define exactly what kind of assertion or what kind of output is expected in the response. You can have multiple assertions. You can introduce wildcards. You can also group and then customize all of your assertions together. Can it be imported or can it be integrated into continuous integration to run the store test during build? If you wanted to pick up Manoj, or if you wanted me to, I can answer.
Yeah, Amit, please go
So
ahead.
the question is, can this be integrated into continuous integration to run the uh, test cases that you have during build?
Amit, please go ahead.
Yeah. So you can absolutely integrate this into Jenkins or any other continuous integration tool. All it provides you is a command line where you can run the tool. You can also give it multiple parameters or tags, and it will appropriately pick up only some of those test suites or test cases. So you will have your own unit test, but this is mainly a functional testing tool, mainly for APIs, which will run after your build has been run, unit tested, and deployed on the QA environment. But it can absolutely be integrated, and there are also a few plugins available on the Jenkins side, which give you enough insights into your test suite execution, how many have passed, how many have failed. You also have the flexibility to customize your reports and what kind of information do you want to present on the Jenkins plugin, as an example. We do have one more question coming in for security testing template. Only what we need, just click on uh, uh,
Create security test while selecting which type we want to do. No need for other configurations on the API. No, it is primarily based on that test case we have already written. So it is already, when you select and then see security test created, it is going to use your functional testing as the base for that, and then it will run on top of it. And selecting the other values, it shows 9 to 10 different testing you wanted to do. That we can select it, which are the parameters or which are the security tests we need to perform. I selected in this case 2 or 3 for simplicity, but we still can generate select those things, and it can run those tests as well, and then it can generate the reports for you.
And we also have one more question, Manoj. And so this will be the last question that we take for today. So the question is about the multiple modules or the kind of licenses that Ready API has. Now, we will urge you to look at the documentation on the website, but in my experience, API test module is all you need. The other modules are kind of specialized, one mainly for performance or for creating your stubs and virtualization. But the API test module in itself is enough for most of your functional and the basic needs around performance and security. With that, this is the end of this webinar, and I would again like to thank each and every one of you who attended this. All of these slides and material will be available online, but we will encourage all of you to reach out to Manoj or me. The contact details are on the screen, and we look forward to having a conversation with each and every one of you pretty soon. Thank you so much.
Thank you, everybody.